Hey guys, years ago I TIG welded this, and I'm going to use this to try and explain how to use a horizontal machining center to profile mill the seam on the shell of the drum. So this represents the drum, and looks like I've got three different locations of the seam here, but if you can imagine that the seam goes all the way across, like on the drum that I was machining the profile, that's what happened. So the first thing I did was I had the drum on the opposite side of the seam, and the drum was chained down on some V blocks. So what I did is I took a 2-inch 4 flute button cutter, or a round insert cutter, and I brought it right to the center of the drum. So I brought it right here, and I basically used a piece of paper and kept cranking the cutter in until the paper wouldn't move. Then I backed the cutter off just a little bit, pulled the paper out, and then I started manually spinning the tool until I saw a very slight chip. Okay, then once I saw the chip, I called this 9 o'clock location Z0, Y0. So the easiest way that I've found to do that is through relative on your screen. So through pretty much every machine I've worked on, they have a deal called relative in your manual offsets. So I went to relative and cleared out the Y and the Z to 0. So on the other side like this, the profile here is nice and round, and you can pick up the profile of what the radius should be on the seam side where you're trying to machine that down. So I picked up Y0, Z0, and then I ended up picking up a total of 7 points. So I picked up 70 millimeters up, 135 millimeters up, 150, and each time I went until I saw a slight chip. A little chip started. So also don't assume that the bottom numbers are going to be the same as the top numbers with regard to where the Z is. Definitely go down below and touch off those. You're probably going to find the same thing I did, whereas the Z is slightly different. And if you really want this profile to turn out nice, you'll definitely go through each point and don't just go until the paper touches. Pull the paper out if you're using paper, and definitely turn the cutter until you see a light chip. So for those of you who don't know what I mean by that, basically you just get the spindle spinning by hand, and you're slowly turning the Z in until you see a light chip start. So you might need a flashlight to really see that chip start. So then you know you're really on the profile of the part. So after you've got your 7 points, or however many points you want to do, picked up, rotate the drum back around, and I just used a manual probe that's got a light and a beep on it, and I put it on the end of the drum and did a visual on that. I didn't beep that off, but I picked up the X by just basically having it right here. I already knew the Y from the bore of the drum, so, and then the Z, I just basically touched the part and called that my Z. So basically, to know what your Z is, you have to know the length of your probe, or whatever you're using. You could use a drill of known length or whatever tool of known length, plus any W of your quill and the Z position. So add up all of those points. If you have no W, obviously it's 0 on the W. So tool plus machine position. Make sure you have it back in machine position, and calculate those numbers down of what that Z is. Okay, so now with all that information, we move over into the program here. I see that this is rolling across the screen here. Wish I could get it to stop doing that. That's annoying. But so then you input where the part is. Call it. I'm using P13, which is 7241 through 7243. XYZ there. 7241 is X, 7242 is Y, 7243 is Z. See if I can get it to stop doing that. I'm going to hit pause. Okay, no cigar and stopping this rolling of the screen. Anyways, so with at the start of the program here, I've got basically a safety line, not necessarily G40, G80, G17 type line, but it's just making sure that the machine is all backed off, and that way if I want to restart here again, I don't have to manually back the machine off. I can just start here, G0, G91, G28, Z0, W0, and then this here is calling up the work offset of P13 with G54.1. Up here, it's indicating where the rotation of the pallet should be. This calls up the tool. Number 100 is 500. So W minus 100 equals 500. And I've got that 500 offset with G52, G43, which is tool length offset of the probe of 60. Then it's Z260. So now we're getting positioned to touch the X on the side of the drum. And this here, if you notice, this is X minus 75, and this is A75. These two match. That way it'll start probing about 75 millimeters away from the drum. It comes in and it probes. This is older probe routine for sure, G101, Q1. All of our other machines don't use that. But it still works good. We don't have protected probing on this machine, but so anyways, then after that, it will set that X location right into P13. And then after that, it'll back away. And then it will shift 7241 over 161.32 where I want the X to really start operating in. So that'll be X0 at that point. So then what you see here, it automatically will set the Z. That the first Z probe is right here. It will touch, and it takes the machine position, number 5023 right after it touches, and it will set that into variable number 102, and then set P13Z number 100 equals 500. Okay, so then it sets it. This P13Z is set, and then it starts to probe all the points. So the drum is basically being probed every 2 inches along here. And then after all that, it will the tool will go to home. M91, it'll shut the probe off. And then the Y is set down lower, I think by 38 millimeters. Okay. And then that first probed point, number 102, as you can see here, number 102 is basically removing the first point from all of these points here, and then it's going to set what it is. So all of these numbers are going to be, plus 2 millimeters all the way to maybe minus 2 millimeters, depending on how the profile of the drum is. So when the machine is cutting this in G19, following the profile, we want it to follow the profile, but yet cut the high spot down. So now down here, excuse me, the 2-inch round insert mill is loaded in. Calls up P13, X15, Y150, which is the very first point. R 984 RPM. And then what you see here is this is the raw numbers of what the profile was on the other side. So R552. Okay, how did I get R552? This, if you calculate the radius of the drum from the center of the drum to the outside of the drum, that is the radius of the drum plus the length of the tool. So you have to add the length of the tool plus the radius of the drum for this to work correctly. So that way it's going to cut a nice arc on there. If you've got 7 points, if you've got 7 points along here, if you've got your radius correct, it's going to just follow that real nice. But if that radius is not correct, it's going to, like if you got your radius too small, it's going to go like this. If you've got your radius too big, it's going to do more of a linear move rather than an arc move. So it's critical that you get your radius correct on these moves. And to do that, you got to know the radius of the center of the drum or the part you're working on plus the length of the tool. So you come up with those two numbers and that will equal whatever it equals. In this case, it's 552. And so all of these, the Y's are just a number I picked up out of thin air. I wanted it to travel a total of 300 millimeters, and Y plus 150 all the way down to Y minus 150 will obviously equal 300 millimeters. But then these numbers here will represent where I saw my first chip on the other side when I was picking those points up. All right, now coming down here, you see the next probed points loaded in here. So this is 103 and 104, okay? The control doesn't know that, but you're programming a whole picture of what's going on in here. So, and here's what I mean by that. So the first 100 equals 50. The first variable that you see here is number 100, x 100. So x is going to move to 50, y 150. Okay. Now 101, if you see 101 here, that equals variable number 103. So that represents the very next probe point after the first one. So now it's going to follow what it was in 103 because 103 got dumped into 101. The answer of whatever your codes are over here, the answer always ends up on the left. So whatever kind of mathematical expression you have, the answer will be here on the left. So when you see number 101 equals number 103, whatever's in 103, which let's say that it's 0.02, that is going to be 101 will equal 0.02. Okay, so now notice this expression here, z minus 20.21 plus number 101. So it's going to take that probed point where the probe touched right here, and it's going to add all that whole thing to each point along here. So that's how that works. So up here, you'll see the same numbers, 20.21, 15.77, 3.67. Well, you see all those same numbers down here, okay? And Z0 is that first number I picked up, okay? Now, and then 101 is applied to all of them so that the machine is correctly moved in or out as it needs to. Now, if you take a look at this, so the machine gets into position Z minus 20.21, and it will come right into the cut, okay? The next thing it does is it changes from G17, which is XY interpolation, to G19. Now, just in case you're not sure what that means, most machining on vertical machining center or a horizontal machining center, most machining is operating in G17, okay? Which equals X, Y interpolation. Okay. G18 equals ZX, G19 equals YZ. So the profile of this part, the arc that's going on here is, what are you seeing happening here? Y, okay, I've got a horizontal machining center, which is my index finger. And you see a movement in Y going on here, Y minus, right? And now you see Z, right? The Z, Y and Z. Well, which one on here is YZ? So I'm trying to make an arc here, right? Is my arc in G17? No, it's in G19. So that's why you see it switch to G19, so that all of these arcs will correctly follow the drum. Now, if I didn't put that G19 in there, all of these arcs would try to either go like this, or like this, depending on G2 or G3. So G2 is clockwise interpolation, G3 is counterclockwise interpolation. So it's either going to go this way or this way. So G3, it moves along the arc of the drum very nicely. But like I said, you got to make sure you add the length of the tool. And then once it's done with the last one, the last point 0.7 right here, then it shifts back to G17, okay? And then the control moves out 50 millimeters or just under 2 inches. Now, the first variable here, variable number 100, this is going to possibly kick out of this loop. It says if variable number 100 is greater than 1875, go to 88, okay? So basically 88 is down here at the bottom where the control will back off and go to home, the home position. So here it says number 100 equals number 100 plus 25. So the number 100, all number 100 is used for here is the X moving over just under an inch equal, each segment. Okay. Now, this is where it gets a little bit complicated. For those of you who haven't seen this type of codes here, I think it's worth explaining. So you see number 147 equals number, and then in brackets number 149. That looks a little bit complicated, but let's break down what that means. So up above on the top, number 149 equals 103, right? You see that? 103. Number 148 equals 104. Number 101 equals number 103. So when you see an expression like this, as we saw on the control, hey, the computer isn't exactly rolling anymore like it was in the beginning. That's good. Excuse me. Here's what this means. Okay, so remember how I said that on the left, the answer is always on the left, okay? So number 149 up above equals 103, right? So does 147 equal 103? Well, what it's trying to say is the number within. So you see this, and you've got to go 2 back. So number 149 equals 103, but this means take the number within, okay? So the number within within variable number 103 equals 0.02. So number 147 equals 0.02. Okay, so that's the exact thing going on in this one as well. Now, the next line here, what this is doing is it's taking these two, adding them up. Oh, the screen's rolling again, I'm sorry. Adding them up and dividing by 2, okay? So if the next one was 0.01, it would add those two up. 0.03 divided by 2 equals 0.015. And then number 101 would equal 0.015, or whatever it is. Number 100, all that is an X move. 100 equals number 100 plus 25. And then now we go through it again, but this here, as you can see, it's the in-between pass. So what I did was I had several probe points along here, like I was talking about towards the beginning of this video. And what I did is I what these are doing here is it's taking this probe point, adding them up, divide by 2 to come up with the center point. And so that way we run an in-between pass here, okay? And then now this below here is setting up for the next pass. Number 149 equals number 149 plus 1. So these two are just counting variables right here, 103 and 104. So it's going to take the next number within and compare them. So as it's going along, 103, 104, so it's going to run 103. Then the in-between pass takes 103 plus 104, adds that up, divide by 2, it's going to run that pass. Then it's going to run the main pass, 104. Then it's going to take 104 plus 105 and run the middle one. And that's how this all works. So, and it keeps looking at if it's at the end, if it's all the way at the end over here, if it's longer than 1875 millimeters or greater than, then it dumps out and it doesn't go into the loop anymore, which is N77. So, well, anyways, I hope that you learned a thing or two about how to mill the profile of a drum. Maybe you learned a little bit about macro programming. And yeah, this here you can do a lot of cool stuff with this. You maybe have seen this on your control, clearing variables. It'll clear them to 0. It'll just keep moving it and clearing them all. Or comparing variables. It's a wonderful tool. So, but anyways, have a great day, and I'll see you in the next video. If you enjoy the video, definitely give me a thumbs up, and I'll catch you in the next video. Thanks for watching.